Imagine waking up one morning to find that dawn never came. The birds never sang, the golden light never spilled across the horizon, and the warmth that has always greeted life on Earth was gone. Above the sky is not the deep blue of day or the star-speckled black of night. It is something in between, a silent void. The sun has vanished. It's a strange idea, almost impossible to truly imagine. The sun has been there for every heartbeat of human history, for every rise and fall of civilization, every whisper of wind through the leaves. It is the great anchor of our existence, the center around which everything, both literally and metaphorically, turns. And yet, for the sake of curiosity, for the sake of science, let's step into this thought experiment and ask, what would really happen if the sun suddenly disappeared? First, we need to understand that the sun is not just a light bulb in the sky. It's the beating heart of our solar system. It accounts for 99.8% of all the mass bound within its gravity. It's what keeps Earth in its perfect orbit, what fuels the photosynthesis that gives us food, and what drives every breath of weather we feel. Without it, everything changes, not gradually, not peacefully, but in stages, each one more profound than the last. Interestingly, though, the change wouldn't be immediate. That's because the information of its disappearance, whether light or gravitational pull, takes time to reach us. Light travels fast, about 300,000 kilometers per second, but it still takes 8 minutes and 20 seconds for sunlight to journey from the sun to Earth. That means for those precious minutes after the sun vanished, we'd continue to see it shining in the sky, unaware of what's already gone. In those final 8 minutes of sunlight, the world would continue as always. People would walk their dogs, the ocean waves would sparkle, and plants would turn their leaves toward the light, unaware that their star was already gone. It's a haunting image, Earth suspended in a fragile illusion of normalcy. Then, at the exact moment that 8 minutes and 20 seconds pass, the light would go out. Instantly, the sky would turn black, even over midday cities. The moon, which only shines by reflecting sunlight, would vanish too, leaving the heavens as they appear from the farthest reaches of space, cold, silent, unending. But the light is not the only thing we'd lose. Along with it, Earth's orbit itself would dissolve. The sun's gravity, which bends space-time and holds the planets in their perfect dance, would also disappear. And that's when things begin to get truly strange. Section 1. The Moment of Darkness. Earth's first hours without the sun. When the last photon from the sun reaches Earth and the light winks out, night falls everywhere at once. There is no sunrise, no sunset, just sudden, perfect darkness. Cities would still glow for a while, lit by their own electric lights, but the countryside and oceans would be swallowed by blackness. The stars would burst into view, hundreds of thousands of them, more than most of us have ever seen, shimmering across the void. The Milky Way would stretch across the sky in brilliant clarity, like a cosmic river. It would be breathtaking and terrifying. At that same moment, gravity itself would shift. The sun's disappearance means that the invisible curve of space-time around it flattens. Earth, which had been moving in a circular orbit around that gravitational well, would suddenly find itself traveling in a straight line, shooting off into space at about 30 kilometers per second. That's 108,000 kilometers per hour. We wouldn't feel it, of course. Everything on Earth, our oceans, atmosphere, and ourselves, would continue moving together. But if you could somehow watch from above, you'd see Earth silently drifting away, leaving behind the empty space where the sun once burned. For the first few minutes, nothing on Earth's surface would seem physically different besides the dark. The air would still be warm from the sunlight that had just been absorbed, and the ground would still hold the memory of heat. But quickly, the temperature would begin to fall. Within a few hours, the world would begin to cool. The average surface temperature of Earth, around 15 degrees Celsius, 59 Fahrenheit, would start to plummet. Within a day, it might reach negative 17 degrees Celsius, 0 Fahrenheit. Within a week, it would fall below negative 40 degrees Celsius. Oceans would begin to freeze from the top down, crusting with ice that thickens as the days pass. The upper layers of the sea would solidify, but below that, water would remain liquid for a long time, insulated by ice and warmed by Earth's inner heat. Deep in those dark waters, life would continue, almost unchanged, for years, perhaps decades. Humans, however, would struggle. Most of our infrastructure, our agriculture, and our very biology depend on the steady energy of the sun. Without it, the global food chain would collapse. Within days, photosynthesis would stop completely. Plants, deprived of sunlight, would wither. Herbivores would starve next, followed by predators. The entire natural rhythm of life would falter and fade. Power grids would fail too, as solar energy becomes useless and fossil fuels begin to freeze in place. Only nuclear and geothermal power could keep pockets of humanity alive for a time, underground, in artificial warmth. But even amidst this chilling scenario, Earth wouldn't become instantly lifeless. In fact, one of the most poetic aspects of this thought experiment is how stubborn life can be. Beneath the ice, in hydrothermal vents on the ocean floor, microbial communities might continue thriving for millennia. The same fiery breath from Earth's molten core that has always powered volcanoes and geysers would keep some parts of the planet warm long after the sun's departure. For the first hours, and even the first few days, Earth would still look almost normal from space. Its blue oceans, its white clouds, its glowing cities. Only the absence of the sun's brilliance would give away the truth that this planet was now adrift, exiled from its parent star, sailing into eternal night. And though it's a grim image, there is something hauntingly beautiful about it too. Imagine standing under that black sky, feeling the last of the day's warmth fading from your skin, and seeing the stars, every one of them a distant sun, still burning somewhere in the vast dark. It's a reminder that even in the absence of our sun, the universe itself still shines. Section 2. The Frozen Earth and the Fading Atmosphere. The first hours after the sun's disappearance are filled with confusion. People everywhere would stare into the black sky, still half expecting dawn to come, still hoping this endless night was only an eclipse or a trick of the weather. But the truth would slowly settle in. There is no coming sunrise. the world has entered a silence that no one has ever known before. As the days pass, the air grows colder. The winds shift and sharpen, sweeping across continents that are beginning to lose their warmth. Without the constant input of solar energy, Earth becomes a planet in free fall toward absolute zero. The transformation is subtle at first, a crispness in the air, frost clinging to windows, rivers stiffening at their edges, but it accelerates with haunting speed. By the end of the first week, most of the world's surface would be well below freezing. The average global temperature, once a comfortable 15 degrees Celsius, would have dropped to around -40 degrees Celsius. The oceans begin to freeze at their surfaces, forming glistening sheets of ice that stretch farther each day. Waves slow, then stop entirely, locked in a glass-like stillness. The once blue Earth now begins to turn pale. Satellite images, if any still function, would show a planet cloaked in white, a world turned to frost and shadow. The cloud patterns that once danced above the oceans fade as the atmosphere itself begins to change. Normally, our weather is driven by the sun's warmth. Its energy powers the circulation of air, the evaporation of water, and the rhythm of rain and storm. Without that warmth, the atmosphere becomes sluggish. Winds die down. Clouds dissipate. The sky, though black to our eyes, becomes eerily still, a frozen dome above a frozen world. But even in this darkness, Earth still has a faint heartbeat, its own internal heat. Deep underground, radioactive decay and the planet's molten core continue to release energy, just as they have for billions of years. This geothermal warmth is weak compared to the sun's power, but it's not nothing. It leaks upward, slowly, through layers of rock and ocean, offering a final breath of comfort to the surface above. Still, for life on land, the situation becomes desperate. Forests, stripped of sunlight, stand silent and brittle. The great green canopy of the Amazon turns gray and collapses under frost. Deserts, once searing, become seas of ice and sand. The polar regions, which were already cold, expand outward until half the world looks like Antarctica. Within weeks, the upper atmosphere also begins to change its chemistry. Without the ultraviolet radiation from the sun, the delicate balance that maintains our ozone layer breaks down. The air grows thinner, heavier. Carbon dioxide and water vapor begin to freeze out, forming delicate crystals that drift downward like shimmering dust. Even the sky itself, once full of invisible motion, starts to collapse toward the ground. In the cities that remain lit, humanity clings to survival. Underground shelters, powered by nuclear or geothermal energy, become sanctuaries of heat and light. Scientists would gather in these outposts, desperate to model Earth's descent and calculate how long life could persist. Some would direct their attention upward, to the stars, wondering whether there was a way to journey toward another sun. But even underground, the cold would seep in. Power plants would strain to keep up. The electrical grids, designed for moderate climates, would fail under the weight of frozen turbines and brittle fuel lines. Pipes would crack, generators would falter, and the surface above would grow quieter and quieter as every living thing succumbed to the endless night. Still, not all is lost. Deep beneath the ice, the oceans hold on to warmth. Water, an extraordinary substance, is less dense as a solid than as a liquid, meaning ice forms at the surface and insulates what lies below. That simple physical quirk, one that has saved life during ancient ice ages, would once again become the guardian of survival. Miles beneath the frozen crust, liquid oceans would remain, warmed from below by geothermal vents. Around these vents, life would continue. Strange creatures feeding on the chemicals spewed from Earth's interior, entirely independent of sunlight. These ecosystems already exist today in the deep sea, where no light ever reaches. They thrive in the darkness, proving that life does not always need the sun. It only needs energy in any form. For millions of years, these deep-dwelling organisms have lived as if they already knew this day would come. They would not notice the loss of the sun. They would go on, thriving in chemical warmth, oblivious to the death of the surface world above. Above the ocean, however, the atmosphere would continue to thin. As the surface cools, gases begin to condense and fall. The nitrogen and oxygen that make up the air would eventually liquefy and settle, forming faint, icy seas on the surface. The sky, in its final act, would collapse onto the earth it once embraced. By this stage, perhaps a few months or years after the sun's disappearance, the planet would become a silent marble drifting through space, its oceans frozen solid, its continents entombed in layers of ice tens of meters thick. Temperatures would stabilize around -240 degrees Celsius, just a few dozen degrees above absolute zero. The only warmth would come from the planet's own heart. And yet, even here, Earth would not be entirely dead. Beneath kilometers of frozen sea, geothermal vents would glow faintly in the darkness. They would release bubbles of warmth and life, perhaps the last living things in the universe that remember the sun. In this new world, time would lose its meaning. Days and nights no longer exist. There is no sunrise, no moonlight, no shadow, only an endless twilight of cold stars. Earth would glide silently through the black, a wandering ghost of what was once a blue world. But there's something quietly beautiful in this vision too. It's the calm after the fire, the stillness that comes when motion ends. The world is frozen, yes, but it is also preserved. Every mountain, every city, every fossil and forest, sealed beneath a perfect glass of ice. If one day, far in the future, another civilization were to stumble upon our frozen planet, they would find it almost intact, like an artifact kept in cosmic storage. They might even find traces of us, our writings, our cities, our machines. and wonder about the great golden star we once orbited, the one that gave us light, warmth, and the spark of consciousness. They might stand in their ships, looking down upon the frozen seas of Earth, and whisper softly into the silence of space. What must it have been like to live under a sun? Section 3. The Drift Through Space. Earth's Journey into the Cosmic Night. Earth is now alone. The great circle it once traced around the sun has vanished. The gravitational tether that held our planet in balance for billions of years has been cut, and the blue world begins to glide, quietly, invisibly, into the deep dark of interstellar space. At first, the motion would be impossible to notice. We do not feel movement through the void, but in truth, Earth is now hurtling forward at 30 kilometers every second. Fast enough to cross the distance from New York to Tokyo in less than a blink. We are a runaway world, leaving behind the place we once called home. The solar system itself remains where it was. The planets nearest the vanished sun, Mercury, Venus, and Mars, would drift outward too, each following its own straight path. The giant planets, Jupiter and Saturn, would continue their frozen journeys, dragging their moons with them. The asteroid belt, no longer held together by the sun's gravity, would scatter across the void like a broken halo. If you could look at this from far above, the sight would be hauntingly beautiful, a once perfect clockwork of motion unraveling into chaos, every world continuing along its last known direction, never to return. The solar system, as we knew it, would dissolve into a faint cloud of wandering planets and debris, spreading slowly through the galaxy like ashes from an extinguished flame. For Earth, this is the beginning of an endless voyage. The stars in our sky remain fixed for now, but over centuries, even they would seem to shift. The constellations would distort as we drift through new regions of space. The familiar shape of Orion, the curve of the Big Dipper, slowly, imperceptibly, would change. We would be travelers now, crossing between the distant arms of the Milky Way, through regions of starlight and shadow. Our journey would last not years, not centuries, but millions of years. And unless something intervened, we would wander forever. In the early years of this cosmic exile, Earth's skies would look dazzlingly strange. With no sunlight to scatter in the atmosphere, the stars would shine with a clarity no human eye has ever seen. Every point of light would be razor sharp, every cluster and nebula radiant against the black. The Milky Way would blaze so brightly that even through the faint haze of Earth's thin, freezing atmosphere, it would seem almost close enough to touch. If anyone still survived underground, scientists perhaps, or small communities living near geothermal vents, they might look up through small periscopes or sensors and see that star field. They would know in the quiet of their shelters that those lights were no longer distant decorations of the night sky, quite literally, the only suns left. Each one of those distant stars is a potential home, an unreachable beacon glowing across the void. As Earth drifts farther, the faint warmth from the sun, its last radiation, fades completely. In the dark vacuum, no trace remains of the light that once painted our world. The space we travel through now is empty and quiet, filled only with the whisper of cosmic rays and the far hum of the galaxy. But Earth itself is not entirely silent. Beneath the frozen crust, tectonic forces continue to move. The molten core still churns slowly, generating a weak magnetic field. The planet's heartbeat continues, hidden beneath kilometers of ice. Over thousands of years, that internal heat begins to create cracks in the ice layers. These fissures occasionally release gas and vapor into the thin atmosphere, sending faint plumes rising upward like sighs from a sleeping world. To any distant observer, Earth might appear to flicker faintly in infrared light, an almost invisible ember adrift in space. If an alien civilization were advanced enough to detect it, they might notice the odd signature of a frozen world still giving off faint warmth from within. They might see it and wonder, was this once a living planet? Did it once orbit a star? They might even send probes, curious to find what remains beneath the ice. And if they did, what would they find? Perhaps they would discover the silent cities, preserved in ice like amber, skyscrapers buried beneath snowdrifts that stretch into the clouds, oceans locked in crystal, mountains untouched for millennia. They might find the remnants of human art, music, writing, our attempts to understand the universe that has now claimed us. They might realize that our species once gazed at the same stars they do, asked the same questions, and dreamed the same dreams. And in that way, even in death, Earth would still tell a story. But for now, there are no visitors. Only time. Centuries become millennia. The last traces of atmosphere freeze and fall, leaving the planet wrapped in vacuum. The continents are buried beneath miles of ice, their shapes softened and hidden. The oceans below remain liquid in places, still home to the descendants of deep-sea microbes that never needed sunlight. Every once in a while, Earth passes through a faint dust cloud or a region of scattered gas. Tiny particles strike the upper ice, releasing brief flashes of light, the soft aurora shimmering faintly, a last memory of what once was day. Over millions of years, gravitational tides from other stars will tug at Earth's path. We may drift through distant regions of the galaxy, where the stars are denser. One day, perhaps after hundreds of millions of years, we might pass close enough to another star to be captured by its gravity. If that happened, something extraordinary could occur. Earth might fall into orbit around this new star, becoming part of a new solar system. It might warm again, its frozen atmosphere turning back to vapor. The ice might melt, revealing the continents below. Oceans could reform. The deep-sea organisms that survived might rise to the surface once more, evolving in the warmth of a different sun. Life might begin again. Not human life, not the same story, but a continuation of something ancient. It's a poetic idea, a world reborn after an endless night, carrying the faint memory of a long-lost civilization under a new dawn. But the odds are unimaginably small. Most likely, Earth will drift forever, an eternal traveler in the cold dark between stars. Still, that image holds a strange kind of peace, preserved and whole. Gliding endlessly through the galaxy, surrounded by the starlight it once admired from afar. And if you imagine yourself standing there, alone on that frozen world, looking up at the stars, you might not feel fear. You might feel calm, because the universe, even in its silence, is still magnificent. We began as stardust born from the debris of long-dead suns. Perhaps it's fitting that one day we return to the dark from which we came. Section 4. The Last Light. How humanity might try to survive. The moment the sun disappears, the countdown begins, not just for the planet, but for humanity itself. In the first hours, no one would truly understand what had happened. News networks would flicker with confusion. Scientists would scramble to make sense of the impossible. But as the days pass and the world grows colder, the truth would settle over humanity like the frost itself. The sun is gone, and it is never coming back. At first, survival would be a matter of improvisation. The global power grids would still run on inertia for a few days, maybe weeks. People would gather in their homes, lighting every bulb, turning on every heater, instinctively trying to hold on to the warmth. Governments would declare emergencies. Leaders would speak to nations by candlelight. The first instinct of the human race would be to reach for light, to push back the darkness, however briefly. But light requires energy, and energy requires fuel. As the surface temperature falls, fuel becomes precious. Oil and gas lines freeze. Wind turbines stop spinning. Solar panels go dark. Only nuclear power remains truly reliable, and even that depends on fragile systems that can only last so long. Within weeks, the lights of most cities would fade one by one. Seen from orbit, Earth's surface would glow faintly for a time, then dim until only isolated clusters remained. Small pockets of stubborn brilliance surrounded by endless black. Those final lights would be humanity's last stars. As temperatures plunge, survival would move underground. Mines, tunnels, subway networks, these would become our refuges. Beneath the earth, geothermal energy could provide heat. Deep in Iceland, Japan, and parts of North America, vast geothermal reservoirs could be tapped to sustain warmth and electricity. Scientists would establish sanctuaries near these regions, artificial ecosystems sealed against the cold. Inside these sanctuaries, life would continue in fragile balance. Artificial light from nuclear or geothermal power would replace sunlight. Crops would be grown in hydroponic farms. Lettuce, potatoes, grains, mushrooms. Each seedling would become precious, each harvest an act of hope. Animals that can live on minimal resources, fish, insects, rodents, would become companions and sustenance alike. Psychologically, though, the darkness would be the hardest enemy. Humans are creatures of rhythm. For millions of years, our minds and bodies have followed the sun, waking, working, and resting in its cycle. Without that rhythm, time itself begins to dissolve. Days and nights lose meaning. The circadian clock, that ancient pulse of life, begins to drift. In the underground shelters, people would begin to lose track of hours and days. The absence of sunlight would blur the boundary between waking and dreaming. The idea of morning and evening would vanish, replaced by an artificial schedule dictated by electric light. Some would adapt, others would fall into quiet despair. Yet history shows that humanity is stubbornly inventive when faced with extinction. In the darkness, new sciences would bloom. Physicists and engineers would work tirelessly to sustain heat and power. Botanists would experiment with synthetic photosynthesis, trying to replicate the energy conversion that plants once performed under the sun. Biologists would modify crops to grow under artificial light more efficiently. The last universities, perhaps now deep underground, would become beacons of knowledge, places where the pursuit of science is not just curiosity, but survival itself. Communication between surviving colonies would be limited. Radio signals could still travel through space, but the atmosphere would eventually begin to collapse, thinning the channels of transmission. Satellites in orbit would drift off course, their solar panels useless, their batteries dying. Before that happens, scientists would likely attempt to create a permanent archive of humanity's knowledge. Massive data vaults stored deep below ground, designed to last thousands of years. They would record not only our science and history, but our art, our music, our languages, the essence of who we were. It would be humanity's message to the future, to the universe, to anyone or anything that might find it. Meanwhile, on the surface, the transformation of Earth would continue. The oceans would be sealed in ice, the continents buried under snow. The air would crystallize and fall. Cities would vanish beneath layers of frost. Their skyscrapers turned to ghostly spires. The world we once knew would become a frozen museum, silent, untouched, timeless. And yet, even in this extreme desolation, some humans might refuse to go underground. A few might choose to remain on the surface, tending fires in the dark, recording their final thoughts under a sky full of stars. They might build great pyres, not for warmth, but for light, a defiance against the void. They would be like monks in a dying world, keeping the last flame alive. Over generations, if humans managed to endure underground, our species would begin to change. Evolution never stops, it only adapts. In the absence of sunlight, our eyes might become larger, more sensitive to faint light. Our skin might lose its pigment entirely. We might become a subterranean species, pale, quiet, and introspective, shaped by the dark. Culturally, our myths and beliefs would transform too. The sun, once a taken-for-granted presence, would become sacred, a divine memory. Songs and stories would be passed down about the age of light, when the skies were blue and the world was warm. The sun would no longer be a star. It would be a legend. In these underground worlds, children born in the darkness would grow up never having seen a sunrise. They would imagine it through the words of their ancestors. The sky was gold. The air was warm. The world glowed. They would paint murals of the lost sun on the walls of their shelters, glowing with the faint light of electric bulbs. It's easy to imagine that after centuries, these underground societies would begin to evolve new philosophies, perhaps even new religions. The sun might become a symbol of rebirth, of lost paradise, or of a promise to someday return to the surface when the world grows warm again. But science, too, would not die. There would always be dreamers, astronomers who gaze upward through sensors and telescopes, tracking the stars that now fill the sky. They would wonder if any of those stars could become a new home. Perhaps they would design great ships, powered by nuclear engines, capable of drifting across the interstellar void to find another sun. It would take millennia to build such a thing. But humans, even when trapped in darkness, have a way of turning despair into invention. We built fire when night first fell upon our ancestors. We built cities when storms tore the forests apart. Perhaps in this endless night, we would build ships that could carry the memory of our species to the stars. The last light of humanity, then, might not be a fire or a city, but a single vessel glowing faintly as it leaves Earth's orbit, carrying the descendants of a species that once lived under a sun. A spark cast into the black, and somewhere, far ahead, another star waits. Section 5, The Silent Skies. What happens to the moon and the other planets when the sun disappears? Its absence doesn't just unmake the day. It unravels the architecture of an entire system. Every world that once orbited that bright star, every moon, asteroid, and particle of dust is suddenly set free. The invisible thread that held them in a delicate dance of gravity has been cut. In that instant, the solar system ceases to be a system at all. For a few precious minutes after the sun's disappearance, nothing would seem to change. The planets would still glide along their paths, unaware that their center was gone. But then, exactly 8 minutes later, the last gravitational wave from the sun would reach them, and all at once, the balance would collapse. Each planet, from tiny Mercury to distant Neptune, would continue moving in the same direction it was heading the moment the sun vanished. No longer curved by gravity, those orbits would straighten into perfect tangents, like marbles rolling off a spinning plate. The solar system would become a spray of planets, each following its own lonely trajectory into the stars. The moon, for us on Earth, the first and most intimate change would be the fate of our moon. For billions of years, it has orbited Earth faithfully, pulled by the subtle tug of gravity that binds the two together. But that relationship was always influenced by the greater power of the sun. When the sun disappears, Earth's orbit changes instantly, and so does the delicate balance that holds the moon in place. At first, the moon would continue circling Earth as before, unaffected by the loss of sunlight, except that it now hangs as a dark, invisible sphere in the sky. No sunlight means no reflected glow. Our once bright moon would vanish completely, swallowed by shadow. Imagine standing on the frozen surface of Earth, looking up at where the moon should be. You would see nothing, only stars, only emptiness. But gravitationally, the story continues. As Earth drifts away from its former orbit, the moon follows along, bound by Earth's pull. The two bodies, planet and satellite, now travel together as a pair, tumbling through space. From afar they would look like a slow, silent dance, orbiting one another as they drift through the void. Over millions of years, the tidal forces between them would still act. The moon might slowly spiral outward, its orbit widening, until one day a passing gravitational field from another star tears it away. The moon might then drift off on its own, becoming a solitary wanderer, an orphan of an orphan world. But for a very long time, Earth and its moon would remain together, partners in exile. Mercury and Venus, closer to where the sun once burned. Mercury and Venus would be the first to drift into the void. Mercury, the smallest planet, would have been blasted by solar radiation for its entire life, its surface scorched and airless. Now, without sunlight, it would quickly lose what little heat it retained. The planet's rocky crust would shrink and crack, its surface temperature dropping to near absolute zero. The craters and cliffs would remain unchanged for eternity, perfectly preserved in the eternal night. Venus, our infernal twin, would undergo a different kind of transformation. Its thick atmosphere of carbon dioxide, which once trapped immense heat, would begin to cool and collapse. The planet that once glowed with temperatures hot enough to melt lead would freeze solid. Clouds of sulfuric acid would condense and fall as frozen rain. Venus would become an icy marble, wrapped in a frozen shroud of gas. The two inner worlds, once blazing hot, would become dead. Crystalline spheres drifting side by side, moving endlessly away from the place where the sun once burned. Mars, always colder than Earth, would quickly become unrecognizable. Its thin atmosphere would freeze and fall to the surface in glittering sheets of carbon dioxide frost. The rusty red color we know today would fade beneath a glaze of white. Its polar caps, already made of frozen CO2, would expand until they met at the equator. But Mars has something Earth does not: the ghosts of ancient civilizations, if only imagined. If future travelers ever found it, they might see the traces of our rovers: Curiosity, Perseverance, Opportunity, now frozen in eternal silence. Their cameras covered in frost, their tracks preserved in dust that will never blow away again. In this new, sunless universe, even our machines would become fossils, witnesses to the age of light that once was. Jupiter and Saturn, farther out. The giant planets, Jupiter and Saturn, would drift as enormous frozen worlds. Without sunlight, their upper clouds would cool and condense, changing color. The golden hues and swirling storms would fade into pale, featureless blankets. The famous Great Red Spot of Jupiter, that massive hurricane larger than Earth itself, would vanish as the atmosphere stills and freezes. But deep inside these gas giants lies immense heat of their own. Jupiter, in particular, still radiates more energy than it receives from the sun, left over from its formation. This internal warmth would linger for millions of years, keeping the planet faintly glowing in infrared light. Around Jupiter and Saturn, their many moons, Europa, Ganymede, Enceladus, Titan, would also freeze. Their subsurface oceans, once kept liquid by tidal heating, would gradually solidify. Titan's methane seas would turn to glass. The ice plumes of Enceladus would fall silent. Yet, deep inside those moons, the same principle that saves life on Earth's ocean floor might still apply. Beneath kilometers of ice, geothermal heat might remain. There, microbes, if they ever existed, could continue to live in slow motion, feeding off the chemical reactions of rock and water. Even without sunlight, some forms of life might persist for millions, maybe billions of years. The outer planets and beyond, Uranus and Neptune, the ice giants, would fade into darkness at the edge of the vanished solar system. Their blue color, caused by sunlight scattering in methane-rich atmospheres, would vanish, leaving them nearly invisible in the dark. Their rings would freeze and disintegrate, spreading into faint halos of debris. Beyond them, the dwarf planets, Pluto, Eris, Haumea, would continue their lonely orbits for a while, then drift into the void. Even farther still, the comets in the Oort cloud, those frozen bodies that once lit our skies with long tails, would remain untouched by heat forever. They would never again be drawn inward to blaze as comets. They would remain dormant and perfect, like snowflakes drifting between the stars. Over billions of years, the scattered remains of our solar system would spread through the galaxy. Planets and asteroids would wander aimlessly, occasionally passing near other stars. Some might be captured, becoming part of new solar systems. Others would roam forever, cold, invisible, and silent. Astronomers call such worlds rogue planets. Even today, we know they exist, billions of them, drifting freely through the galaxy. Some may have lost their stars just as ours did. Others were born in the dark. In time, Earth will join them, a rogue world, carrying the memory of a vanished sun. In the end, the disappearance of the sun is not just the end of light. It is the end of structure, the end of harmony. The solar system that once turned like a perfect clock will dissolve into cosmic dust, scattered across the Milky Way. And yet, in that scattering, something beautiful remains. Because every atom of every world, every rock, every sea, every living thing was born from the ashes of an older star. The sun may be gone, but its matter endures, traveling onward, ready someday to form new worlds, new stars, new beginnings. Even in silence, the universe remembers how to create light again. Section 6. The Vanishing of Light. How the universe would look without our sun. In the first few minutes after the sun disappears, the universe would not seem darker. It would seem emptier. We often imagine the night sky as dark, but true darkness is something few of us have ever known. Even at midnight on Earth, the atmosphere scatters the faint glow of sunlight, still reflecting off the moon, or the dim shimmer of starlight, caught by air and dust. But when the sun is gone, utterly gone, there will be no scattering, no glow, no atmosphere dense enough to cradle even a breath of color. The sky becomes absolute. At midday, when the world should be bright, the heavens would look like deep space, black, star-strewn, infinite. The transition would be so sudden that the human eye would take hours to adjust. For a time, you'd see nothing at all, just void. Then slowly, stars would begin to bloom, sharp and countless. Without the sun, the stars would no longer compete with daylight. Even the faintest and most distant of them would now be visible to the naked eye. The Milky Way, that silver river of light, would dominate the sky. It would arch from horizon to horizon, painted in millions of tiny suns. And for the first time in human history, we would truly see where we are. The sight would be breathtaking. From the surface of a freezing earth, the sky would shimmer like a diamond field. Clusters, nebulae, and other brightness, galaxies, all would be visible in perfect clarity, free from the veil of daylight and atmospheric haze. Astronomers have long built telescopes on mountaintops and in orbit to escape the interference of sunlight. Now, all of Earth would be the world's largest observatory. Yet there would be no one left on the surface to look. The beauty of this new night sky would exist for no witness. The cities, the forests, the seas, all would be frozen beneath the silent spectacle of eternity. It's one of the universe's quiet ironies. In the absence of light, the universe becomes visible. The colors of a dead world. The loss of sunlight would also change how we perceive color, not just in the sky, but everywhere. Under the sun's warm light, the world is rich with hues. Blues of water, greens of leaves, reds of sunset. All of those colors exist because sunlight carries every wavelength of the visible spectrum, scattering and reflecting in endless combinations. When the sun is gone, that full spectrum light vanishes too. Artificial lights might burn for a while. Nuclear stations, geothermal lamps, human fires, but these would cast narrow, uneven glows. Reds and yellows would dominate. Blues and greens would fade. The world would begin to lose its saturation, fading first into monochrome, then into gray. Even if you stood above the frozen surface with a lantern in hand, you'd notice how muted everything feels. The snow would reflect only a pale shadow of color. The air, thin and still, would scatter nothing. In time, there would be no color at all, only shades of black and silver under the light of distant stars. And yet there's an odd calm in imagining this desaturated world. The chaos of daylight, the constant motion of light and shadow, would be replaced by stillness. Every mountain and sea would rest under the same quiet illumination of starlight, equal and eternal. A different kind of day without the sun. Day and night cease to exist. Earth's rotation continues, but there is no light to mark the turning. Time becomes abstract, measured not by sunrise, but by clocks, or heartbeat, or memory. Imagine walking across a frozen plain, the stars unmoving overhead. The constellations don't shift. The shadows never change. You could walk for hours, for days, and never feel that time has passed. The rotation of Earth would still bring subtle variations. The stars would rise and set if one were patient enough to watch. But to the naked eye, it would seem like standing in a photograph of the cosmos, a frozen world beneath a frozen sky. The only visible motion might be that of the planets themselves, still gliding silently through the void. You might see Jupiter as a faint amber disk. Saturn's rings, faintly lit by distant starlight, would shimmer like a ghostly halo. The moon, of course, would be gone. Invisible, black against black. Its orbit would continue, but without sunlight to paint its face, it would vanish from view entirely. For the first time in billions of years, Earth would have no moon in its sky. The universe, once full of familiar markers, would be stripped to its essentials. Stars, silence, and space. How the universe shines without a sun. Though our sun is gone, the universe itself remains radiant. All around, countless other stars still burn. Each one is a sun to some distant world, some unseen planet orbiting in its glow. From Earth's new vantage point, the galaxy would stretch outward in dazzling complexity, a vast, luminous sea. The nearest star, Proxima Centauri, would still shine faintly red in the southern sky, its light traveling just over 4 years to reach us. The Pleiades cluster, the Orion Nebula, the glow of Andromeda, all would remain visible, eternal reminders that our sun was never unique, only close. On longer timescales, though, even this cosmic light would shift. As Earth drifts farther from its original orbit, the perspective of the stars changes. The constellations we once recognized, Orion, Cassiopeia, the Big Dipper, begin to distort. Over tens of thousands of years, their familiar patterns unravel. Stars move relative to one another, the geometry of the sky twisting into new forms. To future observers, if any survive, the night sky would be both familiar and alien. The same stars would exist, but rearranged, a reminder that nothing in the universe stands still. And as we drift deeper into the Milky Way, new lights would appear. Earth might pass near nebulae, glowing clouds of gas where stars are born. Their faint colors, blues, purples, greens, would spill across the sky like cosmic auroras. For a time, the frozen planet might sail through a corridor of beauty, a spectral dance of distant fires. But eventually, even that light would fade as we pass beyond the galactic plane into emptier space, the last flickers of human light. If humanity still endures, the sky would remain an anchor, our one connection to the cosmos. In the underground shelters, astronomers would aim telescopes upward through ice tunnels and periscopes, studying the universe that now glows above them. They would record the starlight, measure the faint radiation that still seeps through the cosmos, the afterglow of the Big Bang itself. They might even find comfort in it, because in that faint, ancient light, we can still trace our origins. Every atom of our bodies, every crystal of the frozen earth, was born from the death of earlier stars. The universe is dark, yes, but it is also luminous in memory. In that way, even without a sun, light never truly vanishes. It simply moves elsewhere, carried in photons that have been traveling since before there were eyes to see them. And if you stood on the surface of Earth, wrapped in the cold silence, and looked up one last time, you might feel something unexpected. Not fear, not sorrow, but a strange peace, because the stars, so distant and ancient, would still whisper the same message they always have. We are still here. We were always here. Section 7. The Collapse of Time. How days, seasons, and memory disappear. The sun has always been our clock. Even before we understood what time truly was, before we carved calendars or invented hours, the rising and setting of the sun divided existence into the simple rhythm of day and night. That golden heartbeat of light and dark shaped every living thing on Earth. When the sun disappears, that heartbeat stops. At first, the world still turns. Earth keeps spinning, as if refusing to believe the light is gone. The invisible rotation carries the planet faithfully around an empty point in space. But there's nothing to orbit anymore. No warmth, no glow, no dawn. And with that, the fabric of time begins to dissolve. The death of the day. Without sunlight, there can be no day. Every part of the planet exists in permanent darkness. The words morning, afternoon, evening lose their meaning. If you looked at a clock, the hands would still move, but they'd no longer match anything that feels real. Time would become something abstract, detached from nature, ticking on without purpose. Humanity has always measured time by the movement of light, the way shadows shift, the way the air changes color, the way the sun climbs and falls. Without it, our sense of time doesn't just vanish, it collapses inward, becoming chaotic and personal. Survivors hidden deep underground, if there are any, would lose track of hours and days almost immediately. The body's circadian rhythm, that delicate internal clock synchronized with light, would start to falter. People would sleep and wake unpredictably. The concept of night's rest or day's work would no longer apply. Over weeks, the psychological effects would deepen. The human brain, evolved for cycles of light and dark, becomes confused without them. People might begin to hallucinate the glow of the sun, dreaming of light they will never see again. In silence and perpetual cold, time would stretch and contract strangely. A minute could feel like an hour, or a day could vanish in an instant. The end of the sun, it turns out, is also the end of time as we know it. Seasons without a sun. Beyond the day, the sun also gave us our year. The tilt of Earth's axis, its slow orbit, creating the dance of seasons. Spring's warmth, summer's heat, autumn's glow, winter's chill, all born from the changing angle of sunlight over the curve of the planet. Now that rhythm has ended. There are no longer seasons, only temperature falling toward the same final point, absolute zero. The planet that once swelled and breathed with heat and ice becomes uniform, still. The forests that once turned gold in autumn now stand frozen in perpetual winter. Rivers that once thawed with spring remain locked beneath kilometers of ice. Even the winds, once driven by the uneven heating of air, will stop. The atmosphere itself will collapse under its own weight, freezing into layers of nitrogen frost. Earth will no longer move through time. It will simply be a monument to what time once meant. And yet, in a strange way, this frozen stasis carries its own beauty. The chaos of weather, the constant churn of change, ends in a silence so perfect, it becomes almost holy. The air no longer stirs, the oceans no longer roar. The world becomes timeless, and in that timelessness, serene. The clocks that keep ticking, somewhere deep beneath the surface, in old observatories and forgotten shelters, machines might still mark the passing of seconds. Atomic clocks would continue to vibrate in their perfect rhythm, even without the sun to measure against. They would keep time with incredible precision, but for what? A clock only matters when there's something to synchronize it to. Without the sun, seconds become meaningless. There are no more harvests, no more school days, no more years to count. The Gregorian calendar, the heartbeat of human civilization, would freeze at its final date. If one were to find an ancient digital display, still powered by some surviving battery, it might still show the time, 11:23 or 5:47, unaware that there is no longer a morning or evening. Time has lost its anchor. In this world, even eternity feels weightless. Memory and the drift of mind. Time and memory are twins. The human mind understands life as a sequence of moments. This happened before, that will happen after. But when time stops flowing, memory begins to blur. In the eternal night of Earth, survivors would lose their grip on chronology. Events would melt together as if happening all at once. You might recall something from yesterday, but what does yesterday mean when every hour looks the same? Over generations, if any survive that long, even history itself would fade. Children born in the dark would have no concept of day. They would know only the faint glow of artificial light, torches, electric lamps, geothermal fire. To them, the sun would sound like mythology, a dream of golden warmth told by trembling voices. And maybe that's what it would become, a myth, humanity's oldest and truest god, reduced to legend. Perhaps they would draw its circle on walls, carve rays into the ice, whisper stories of a time when light fell freely from the sky. And in doing so, they would begin to rebuild something resembling time again, not measured by rotation or orbit, but by remembrance. Because memory, too, is a kind of sunlight. It warms the dark. The cosmic clock, yet even though time on Earth would crumble, the universe itself continues. Stars still burn, galaxies still turn, gravity still bends space. The cosmic clock keeps ticking, indifferent to our loss. On scales far greater than human thought, time flows endlessly. In 1,000,000 years, Earth will have drifted beyond its old orbit, an unlit marble wandering through the void. In 1,000,000,000, it may pass near another star, its frozen seas glinting faintly in the borrowed light. Perhaps that star's gravity will capture it, pulling Earth into a new orbit. And when that happens, for the first time in eons, light will touch its surface again. The frost will crack, the ice will steam, and maybe, deep within the buried oceans, something ancient will stir. Time will begin again. The stillness between seconds. There's a strange beauty in imagining a world without time. The rush of hours, the panic of calendars, all of it gone. What's left is stillness, a purity untouched by motion. Perhaps, if you were to stand on that silent planet and look into the endless black sky, you might not feel despair at all. You might feel peace. The sun's disappearance isn't just destruction. It's also release. Release from the ticking of clocks, from the passage of seasons, from the burden of endings. In that eternal quiet, Earth becomes a perfect statue, a frozen testament to all that once lived, breathed, and dreamed beneath the sun. And maybe, just maybe, that's the most beautiful end of all. A world no longer racing against time, but finally resting within it. Section 8. The Frozen Earth, Oceans, Winds, and the Death of Weather. When the sun disappears, the first thing Earth loses is not warmth, but motion. For billions of years, sunlight drove every current of air and sea. The winds, the storms, the rain, the breath of the planet. All of it came from uneven heating, the sun warming one part of Earth more than another, creating a constant circulation of energy. Without that heat, the balance collapses. In the first few hours, the atmosphere still moves, not because of warmth, but because of memory. Winds continue to swirl from momentum alone, carrying the last echoes of vanished weather patterns. But slowly, inevitably, they weaken. Each gust becomes thinner, colder, more fragile. And then one day, perhaps only a few weeks after the sun's disappearance, the air falls still. It is the death of weather. The first freeze. At first, the cooling is gentle. For a few days, temperatures fall like a long winter settling in. 0 degrees Celsius, then negative 20 degrees Celsius, then negative 50 degrees Celsius. The oceans release their stored warmth, radiating it back into the blackness of space. Within a week, the surface of the seas begins to harden. At the poles, the ice thickens rapidly. Near the equator, waves still roll, though sluggishly. Steam rises from them, ghostly in the darkness, the last breath of the living ocean. By the second week, the upper layers of the oceans start to crystallize. Ice spreads outward from the coasts, forming smooth, glass-like sheets. The world's great currents, the Gulf Stream, the Pacific Drift, the Antarctic Circumpolar, begin to slow and stop. The oceans, which once sang with motion, fall silent. Under the ice, water still moves, slow, black, dense, carrying with it the last traces of warmth from Earth's core. It will take centuries for the deepest oceans to freeze entirely. But on the surface, the transformation is complete. The world becomes a frozen mirror, the death of rain. With no sun to evaporate water, clouds can no longer form. The great cycles of condensation and precipitation stop forever. There are no more storms, no lightning, no thunder. The air, once filled with moisture and movement, becomes dry and empty. Snow may still fall for a while, as vapor left in the atmosphere crystallizes and drifts down softly, but eventually, even that ends. Imagine standing in that eternal twilight, watching the last snowfall Earth will ever know. The flakes fall slowly, silently, sparkling faintly in starlight. When they settle, they never melt. Each one becomes a tiny monument, a frozen signature of the last weather on Earth. The frozen air. As the world cools further, even the air itself begins to change. At negative 100 degrees Celsius, the carbon dioxide in the atmosphere starts to freeze. Fine white crystals fall from the sky, coating the ice below in a soft, powdery frost. Then, at negative 200 degrees Celsius, nitrogen, the main component of our air, condenses and freezes, forming sheets of pale ice that blanket the ground. The atmosphere collapses. What was once an ocean of air becomes a thin layer of frozen gas, glittering faintly in the starlight. Standing on Earth's surface, there would be no wind, no pressure, no sound. Your breath, if you could survive to see it, would crystallize instantly and fall at your feet. The planet becomes an airless sphere, wrapped in its own frozen breath. The silence of the oceans. Beneath the surface ice, a hidden world persists, for a time. The deep ocean retains warmth from geothermal vents at the seafloor, those black smokers that spew heat from Earth's molten interior. Around them, in the dark, life could continue. Tiny microbes, strange worms, blind shrimp, they thrive today around such Venice, needing no sunlight at all. Even after the sun's disappearance, these creatures might live on, feeding off the chemical energy from below. In that sense, life on Earth would not end, it would retreat. It would sink deeper and deeper, until only the deepest trenches still carry the spark of motion. For hundreds of thousands of years, pockets of liquid water would remain trapped under kilometers of ice. These buried oceans would become the last refuges of life. Silent, self-contained worlds, but even they cannot last forever. Eventually, as the surface freezes solid and heat leaks into space, the ice will thicken until it reaches the seafloor. When that happens, the oceans will be sealed. The world's heart will stop beating. The shattered sky, the death of weather brings another strange phenomenon, the quiet collapse of the sky itself. Without the sun's warmth, the gases in the upper atmosphere cool and contract, creating immense pressure differences that ripple downward. Layers of frozen nitrogen and oxygen begin to crack and break, sending glittering fragments drifting through the thin air. From the ground, it would look like slow-motion auroras, sheets of pale blue ice drifting above, catching faint starlight as they fall. The sky, once alive with clouds and storms, becomes a cathedral of crystal, and then silence. The air becomes so still that even sound stops carrying. A whisper, a breath, would travel only a few centimeters before vanishing. The last echoes of wind fade. The planet forgets the sound of its own voice. The sculpted earth. Once the oceans freeze and the air solidifies, Earth's surface enters its final transformation. The glaciers that once moved like slow rivers of ice will stop flowing. Mountains will no longer erode. Sand dunes will freeze in place. The entire planet becomes a single, unchanging sculpture. Deserts remain deserts, frozen beneath layers of frost. Forests stand like black silhouettes encased in ice. Cities, if any remain intact, become crystal tombs, each window rimmed in frozen air, each street silent beneath layers of glassy snow. The continents will look much as they do now, but petrified, unmoving, eternal. It's as if the world has been caught mid-breath. The beauty of stillness. There's a haunting beauty in imagining this frozen earth. The chaos of wind and rain, the endless rise and fall of tides, are replaced by a profound serenity. Every wave, every leaf, every grain of sand holds still, as if the planet itself has finally found rest. Even the light that reaches it from distant stars moves too slowly to warm it, but enough to reveal the contours of its frozen face. Seen from space, Earth would be breathtaking, a flawless marble of silver and white, glimmering faintly against the blackness of eternity. It would look peaceful. It is peaceful. And though life has retreated or perished, though no wind stirs and no water moves, the silence itself feels alive, as if the memory of motion still hums faintly beneath the ice. Because every frozen sea, every still mountain, once burned with sunlight, and even now, in the endless dark, that memory remains. Section 9. The Heart Within. How Earth's core keeps beating beneath the ice. The world above has frozen. The air has turned to crystal, the seas to glass, the winds to silence. But deep below that unbroken surface, the earth still breathes. It is faint, ancient, and slow, but it is there. Because even without the sun, the planet has its own fire. The fire that was born with the world 4.5 billion years ago, when Earth was young. It was not blue or green. It was molten, an ocean of magma, boiling and alive. Over the eons, that fiery chaos cooled, forming crust and ocean and sky. But the heat inside never vanished. It came from 3 sources: the leftover warmth of Earth's formation, the slow compression under its own gravity, and the quiet decay of radioactive elements deep inside: uranium, thorium, potassium, all releasing energy grain by grain, second by second. That internal fire is why volcanoes erupt, why continents drift, why the magnetic field hums around us like an invisible shield. Even now, billions of years later, that heat remains. And when the sun disappears, it becomes the last warmth left to us. The depths beneath the frost. Beneath the frozen crust, the temperature rises quickly. The first 100 meters are solid ice, clear and hard as stone. Below that, the ice grows denser, pressed by its own weight. But as you go deeper, down 1 kilometer, 2, 5, the heat from the planet begins to fight back. At 10 kilometers down, the rock is warm enough to soften the base of the ice. Liquid water may still flow in hidden veins, trapped and glowing faintly from geothermal warmth. This is the beginning of Earth's hidden ocean, an entire world sealed beneath the frost. Farther still, the crust gives way to the mantle, a vast, slow river of rock that moves like thick honey over ages. Here, heat and pressure are immense. Minerals deform, melt, reform. The planet's internal cycle continues, indifferent to the silence above. Even though the surface has stopped changing, the deep earth still churns, slowly, quietly, tirelessly. It's as if the planet's soul refuses to die. Volcanoes in the dark. For centuries after the sun's disappearance, volcanoes would still erupt. Not often, but occasionally, bursts of molten fire breaking through the ice, sending rivers of red across the frozen plains. The contrast would be extraordinary, a jet of glowing magma rising through kilometers of crystal frost, lighting the black sky with orange and gold. Seen from orbit, each eruption would look like a heartbeat, tiny, bright pulses on an otherwise lifeless sphere. Eventually, as the planet cools further, these volcanoes would fade. The crust would thicken, harden, and seal. But for a long time, they would stand as symbols of resistance, proof that even in darkness, Earth remembers how to burn. The magnetic pulse, As long as the core remains molten, Earth's magnetic field endures. This invisible field, generated by the motion of molten iron and nickel in the outer core, has always been our unseen guardian. It deflects radiation, shapes auroras, and connects us, literally, to the invisible rhythm of the universe. Even without sunlight, the dynamo continues to turn. The molten metals swirl under immense pressure, generating electric currents and magnetic waves. If one could somehow stand on the surface, armed with sensitive instruments, you'd still detect the magnetic whisper of the planet beneath your feet, a soft, steady hum against the cosmic silence. But nothing lasts forever. Over millions of years, as the interior cools and the liquid outer core begins to solidify, the dynamo will weaken, the field will flicker, then vanish. The auroras that once danced at the poles will fade into memory. The magnetic pulse of Earth, the last movement of its invisible heart, will finally stop. The secret ecosystems below. Before that happens, life might find a way to follow the warmth downward. Already, even in our living world, entire ecosystems thrive deep below the surface. Bacteria that feed on minerals, archaea that consume hydrogen and sulfur, organisms that have never seen sunlight. Some live miles underground, within tiny pockets of water, trapped in rock. Others cling to the walls of geothermal vents, surviving in heat and pressure that would destroy any surface creature. When the sun disappears, these will be the last living things on Earth. They will retreat deeper into the mantle's fractures, following the faint warmth of the planet's core. They will feed not on sunlight, but on the slow chemistry of stone and metal. For millions, perhaps tens of millions of years, these microscopic colonies could persist, each one a glowing ember of life, flickering beneath kilometers of deathly cold. The surface may be frozen solid, but below it, life still stirs, ancient, patient, almost eternal. The slow cooling. Over eons, the internal heat will fade. The radioactive decay that once powered Earth's heart will slow as those elements are consumed. The mantle will stiffen, convection will weaken. Volcanoes will stop entirely. The crust, once flexible, will become brittle. The planet will enter its final phase, a solid sphere of stone racked in frozen air, its heart cold and still. But even then, the cooling process will take billions of years. Earth will not die quickly. It will fade with dignity, its warmth retreating inch by inch toward the center, until only a small molten seed remains. In a way, that final ember is beautiful. It means that even when all motion ceases, something deep within still glows, a heart remembered. From the surface, the frozen world appears utterly still. But if one could somehow listen, not with ears, but with instruments sensitive to vibration, you would hear faint murmurs beneath the ice, tiny earthquakes, the crack of shifting plates, the slow pulse of molten rock far below. Each sound would be a whisper from the planet's heart, a message sent upward through stone, saying simply, "I am still here." And maybe, if intelligent life ever returns, creatures from another star drifting through space, they might land on this silent world and dig. They might drill through ice and rock until they find the warmth beneath. And there, in the depths, they might discover a trace of life still clinging to that ancient fire. They would realize that Earth, though frozen, never truly died. It merely went quiet, the final ember, Billions of years from now, when the core has solidified completely and all radioactive decay has ceased, the last heat will radiate outward and vanish. At that moment, Earth will become like the moon, cold, inert, silent. Its once molten heart will have turned to iron crystal, unmoving. And yet, that crystal will hold within it the memory of everything that ever lived above it. The magnetic fields it once generated, the continents it once pushed, the volcanoes it once birthed, all frozen in perfect detail within the lattice of its core. That is how Earth will end, not in fire, not in chaos, but in quiet endurance. A heart that burned for billions of years, finally resting. Section 10. The Fate of Life. The Last Survivors and the Quiet Evolution of the Deep. The sun is gone. The world above is a monument of stillness. Oceans sealed beneath miles of ice. Forests entombed in glass. Cities buried under glittering frost. But deep below, in cracks and caverns, life whispers on. It is no longer the life we know. It does not bloom or sing or run through meadows. It moves slowly, almost imperceptibly, in darkness thicker than any night. Yet it is life, patient, enduring, beautiful in its persistence. The descent of life. When the sun first vanished, surface life vanished with it. Plants died within weeks, deprived of light. Herbivores followed, then the predators. Within a few months, the biosphere, everything we once called alive, collapsed into silence. But extinction is never total. In the deep oceans, around the hydrothermal vents that line the mid-ocean ridges, there existed creatures that had never seen sunlight even before. They fed on the chemicals spewed from the Earth's interior: hydrogen sulfide, methane, iron, and minerals dissolved in boiling water. As the surface froze, these ecosystems continued. For a time, they were safe, fed by the heat of the planet and the chemical energy of its restless mantle. Tube worms, giant clams, and colonies of microbes thrived in the darkness, unaware that their world above had died. And when the ice above thickened and the oceans began to freeze from the top down, these vent communities remained alive beneath a ceiling of solid ice, glowing faintly in the shadows like embers in an infinite cave. The age of microbes. In the end, it is the smallest that endure the longest. Microbes, single-celled organisms that can survive radiation, heat, cold, and pressure beyond any animal's tolerance, become the rulers of the earth once more. They slip into the cracks between rocks, cling to minerals, and feed on the faint trickle of chemical energy still flowing through the crust. Some use sulfur. Some feed on hydrogen released by the slow grinding of tectonic plates. Some consume iron and exhale methane. These microbes do not need sunlight. They do not need air. They live so slowly that a single cell might take centuries to divide. But even at that glacial pace, they are alive. And life, no matter how slow, means change. Over generations, measured not in years, but in millennia, these organisms begin to adapt to their eternal night. They evolve to tolerate colder temperatures, lower energy, higher pressure. They become more efficient, smaller, quieter, until life itself is almost indistinguishable from the minerals that surround it. Living rock, pulsing faintly with biochemical light. the hidden biomes beneath the ice, far beneath the continents, kilometers down into the crust. There are aquifers, pockets of liquid water, sealed off from the surface since before humanity existed. Today, on our living Earth, scientists have already found bacteria and archaea thriving there, feeding on rock chemistry alone. When the sun disappears, these sealed worlds will become the last refuges of life. Imagine a cavern the size of a city, filled with warm, dark water. The walls glow faintly with bioluminescent microbes, their light soft and green. Drifting in slow currents, there is no sound except the gentle movement of bubbles, no motion except the turning of invisible life. These caverns become the last oceans of Earth, unseen, silent, perfect in their solitude. The long winter of evolution. Time stretches on, 1,000 years, 1,000,000, 100,000,000. The microbes persist, evolving in the dark. Without sunlight, there is no need for vision. Without predators, no need for speed. Evolution slows to a crawl, not toward complexity, but toward endurance. Eventually, perhaps, new forms arise, not large, not quick, but uniquely suited to the frozen planet. Creatures that drift through subsurface lakes, feeding on mineral energy, communicating through vibrations or faint pulses of bioluminescent light. A biosphere of quiet forms, each adapted to scarcity. They do not dream of the stars or of warmth. They know only the slow rhythm of chemical exchange. The conversation of stone and water and time. They are the children of darkness, born from what the sun left behind. The memory of humanity. If anything of us survives, it will not be flesh. Perhaps our cities remain frozen, preserved like fossils under transparent ice. Perhaps data, etched into metal, lies buried and unread for millions of years. Maybe one of those deep microbial colonies will one day encounter the remnants of our world, a buried reactor core, a preserved artifact, a sealed vault still radiating faint warmth. The microbes will not understand, but they may feed on it, and in doing so, they will carry a trace of us forward. Atoms, once part of our hands and thoughts, now part of their metabolism. In that way, humanity lives on, not through memory, but through chemistry. We become part of the same slow conversation of minerals and microbes that continues long after the stars have forgotten us. When even the deep grows cold, eventually, even the geothermal warmth will fade. The core will cool. The hydrothermal vents will shut. The last pockets of liquid water will freeze into crystal. But the final microbes will not die easily. Some will form spores, tiny indestructible shells, capable of waiting millions of years for a moment of warmth that never comes. They will lie dormant within the stone, fossilized but not dead, like seeds waiting in a field of eternal winter. And perhaps, one day, if another star drifts close, or if cosmic debris brings heat again, they will awaken. They will divide, multiply, feed, and begin the long journey of evolution once more. Life reborn from its own ashes. The meaning of survival. There's a quiet poetry to this image, that even in a universe without the sun, life does not surrender. It merely slows, adapts, transforms. It doesn't rage against the dark. It joins it, learning to exist within the silence, sustained by its own persistence. In that way, Life mirrors the universe itself, patient, vast, eternal in its cycles of birth and stillness. And perhaps that is the ultimate truth of our world, that life never truly ends. It only changes form, from sunlight to chemistry, from motion to memory, from brilliance to the soft hum of survival. In the frozen core of a lifeless planet, there is still movement, still warmth, still being. The surface may have gone cold, but the idea of life, the pattern, the instinct, the quiet will to continue, remains. And even when the last cell fades, the record of its struggle will endure in stone, as though the earth itself remembers, because memory, too, is a kind of life. Section 11. The Eternal Night Sky. How the Universe Looks Without the Sun. The last rays of sunlight have vanished. No dawn, no dusk, only night, stretching endlessly in every direction. But the darkness is not empty. Without the glare of the sun, the sky unfolds into something vast and breathtaking, a cathedral of stars we were never meant to see while blinded by daylight. The disappearance of the sun has turned Earth into an island of shadow, but the universe beyond shines on, untouched, eternal. The first night that never ends. The moment the sun vanishes, the sky changes forever. At first, for 8.5 minutes, nothing happens. Light still travels through space, the last wavefront of sunlight racing toward Earth. Then, suddenly, it ends. Daylight collapses. A curtain falls over the world. The blue of the sky fades to a deep, crystalline black. Stars burst into existence, not gradually as they do at twilight, but instantly. Billions of them, scattered like grains of light across the cosmos. Where once the sun dominated the heavens, now there is only infinity. And for the first time, Earth's inhabitants, if any still looked upward, would see the universe as it truly is, the return of the hidden stars. Our sun is bright, but it also blinds. Its light scatters through the atmosphere, hiding the stars behind a veil of color. Without it, every layer of the cosmos becomes visible at once. The Milky Way, once a soft silver band, now stretches across the entire sky like a river of fire. Each cluster, nebula, and spiral arm becomes distinct. You could trace the edge of our galaxy with your eyes, watch it curve into infinity. Beyond it, faint galaxies emerge, billions of distant spirals, glowing softly against the black. Some are so far away that their light left before Earth ever formed. Now, without the sun, that ancient light can finally be seen. It's almost ironic. In losing our own star, we gain sight of every other. The planets adrift. The solar system, too, is still there, but changed beyond recognition. Without sunlight, the planets no longer shine by reflection. They drift as invisible shadows, lit only by the faint gleam of distant stars. Mercury and Venus vanish completely, swallowed by darkness. Mars, once red and bright, becomes a black silhouette against the faint background of the Milky Way. Jupiter, with its great storms and shining moons, becomes a ghost. Its clouds now unseen, its rings invisible. And Earth, once radiant with blues and greens, now turns black. From space, it's just another cold, silent rock drifting in the dark sea of the cosmos. Only the faint infrared glow of its own geothermal heat gives it away, a ghostly ember in an endless night. The dance of moons and shadows. Even without sunlight, motion continues. Gravity still holds the planets in their orbits. For a time, the moon still circles Earth, locked in its familiar dance. But without the sun to light it, the moon is invisible, a perfect black disk crossing an infinite black sky. Only when it passes in front of a background star does its silhouette betray its presence, a brief eclipse in miniature, like a shadow moving across eternity. The other moons of the solar system, Europa, Titan, Ganymede, and Enceladus, all drift through their own dark orbits, their frozen oceans locked beneath miles of ice. For the first time, the solar system has become truly solar no more. It is a quiet ballet of invisible worlds, moving in patterns only gravity remembers. The glow of the galaxy. From Earth's surface, though, there is still light, a new kind, softer and far older. Starlight, pale, steady, eternal. If you stood on the frozen surface of Earth, bundled against the cold, and looked up, your eyes would eventually adjust. You would begin to see light everywhere, not bright, but infinite. The Milky Way's galactic core would dominate the horizon, its dense star fields glowing like molten gold against the black. You'd see faint purples and blues from distant nebulae, pale threads of interstellar dust, and maybe even the faint shimmer of Andromeda, our neighboring galaxy, now visible with perfect clarity. For the first time, the sky would be pure, no light pollution, no atmosphere scattering, no glare. Just the raw architecture of the universe. It would be overwhelming, not bright, but infinite. Cosmic silence, and then, after wonder comes silence. Without the sun, the solar wind ceases. The magnetic storms that once danced between sun and planet fade into stillness. Earth's magnetosphere remains for a time, humming faintly, but the solar system itself grows quiet. The heliosphere, the vast bubble of charged particles blown outward by the sun, collapses inward. For the first time in billions of years, the interstellar medium flows freely through the space once claimed by sunlight. We rejoin the galaxy. Our star's long breath is gone. It's as though the entire solar system exhales and becomes part of the greater cosmos once again. The light that still travels, though the sun is gone, its light remains on a journey. Photons that left the sun moments before its disappearance are still traveling outward, across the solar system, toward the outer planets, beyond Pluto, past the edge of the Oort cloud. For months, then years, its light continues, reaching distances where it will never be seen, yet always moving forward. Even after the sun's final flare fades from sight, its light will still be racing through the void, passing other stars, crossing other galaxies, forever carrying a memory of what once was. Somewhere, billions of years from now, that light may reach another civilization. And when they study it, they might see the spectrum of a yellow star that no longer exists, a ghost of warmth in a universe of cold, a universe reclaimed. Without the sun, Earth becomes a true member of the cosmic order, not a world defined by its star, but a fragment of infinity itself. The night sky, once something we glanced at between days, becomes eternal. There is no more horizon, no more cycle, no more morning, only the deep, endless turning of stars. If consciousness still lingers in some machine or mind or fragment of memory, it would see the sky not as a loss, but as revelation, because in the absence of our sun's light, the universe reveals its own, the quiet majesty of darkness. We often think of darkness as the absence of something, but here, in this eternal night, it becomes a presence all its own, vast, serene, alive with distant fire. The stars are not gone. The galaxies still burn. The universe continues to breathe, to expand, to create and destroy and shine. The sun's disappearance is not the end of light, only the end of our light. And maybe that's the final lesson of the eternal night sky, that the cosmos does not mourn. It simply continues, indifferent, magnificent, eternal. Above the frozen earth, space itself glows with quiet splendor. The Milky Way ripples like silk, and distant galaxies shimmer like memory. In the deepest dark, there is still beauty, still light, still wonder. It is not the end of everything. It is simply the beginning of forever night. Section 12. The drift of the planets. The solar system without its sun. The sun is gone, not exploded, not dimmed, simply vanished. And in that instant, the invisible thread that held every planet in its graceful orbit is severed. For 4 centuries, the solar system had been a cosmic clock, every planet turning with perfect rhythm around the golden center. Now the clock has stopped, but its gears are still spinning, scattering slowly into space, each one moving along its own endless silent line. The moment gravity breaks, when the sun disappears, its light takes 8 minutes and 20 seconds to reach Earth. Its gravity vanishes at the same moment, not instantaneously, but traveling at the speed of light as well. That means for 8 minutes, everything seems normal. The planets continue their orbits. The moon still circles Earth. Space remains calm. Then, at once, the invisible center of gravity ceases to exist. The fabric of space-time that curved gently around the sun relaxes, flattening in an instant. The planets, which had been orbiting along curved paths, now fly straight, no longer held by any pull, their inertia carrying them forever forward. Earth's trajectory into the void. Earth doesn't fall into chaos, it simply drifts. At the moment the sun's gravity disappears, our planet is traveling at about 30 kilometers per second, or 108,000 kilometers per hour. That velocity now becomes its path through the galaxy, a straight line tangent to the orbit it once followed. Imagine a stone whirled on a string. Cut the string, and the stone flies off, not toward the center, but along the direction it was moving the instant the tension released. That is Earth now, a cold, dark world flung outward, forever leaving the orbit that once gave it day, night, and season. The same happens to every other planet. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all drift away at their orbital speeds, scattering like pearls from a broken necklace. The paths of the outer planets. The giants of the solar system, Jupiter and Saturn, carry the heaviest burden. Their gravity, though weak compared to the sun's, still influences dozens of moons and smaller bodies. For a while, their miniature systems remain intact. Jupiter keeps its moons, Europa, Io, Ganymede, Callisto, each one still orbiting the gas giant as if nothing had changed. Saturn's rings still shimmer faintly in starlight. Its icy moons still circle in elegant resonance. But over time, without the sun's stabilizing pull, even these systems begin to drift apart. Tiny perturbations accumulate, orbits wobble, and one by one, the moons slip free. Some crash into their parent planets. Some are ejected, becoming lonely wanderers of interstellar space. The beautiful architecture of our solar system dissolves, not in violence, but in slow unraveling. The moons that keep orbiting Earth's moon remains with us for a while. Bound by Earth's own gravity, it continues to orbit, faithfully circling the frozen planet every 27 days. From the surface, you would not see it. It's pitch black, lit only by the faint reflection of distant stars. But if you could somehow illuminate it, you'd find that the moon has become a silent twin, a companion drifting beside us into infinity. Over time, tidal forces still act between Earth and moon, though more slowly now that both are cooling. The moon will slowly drift away, as it always has, until even its orbit becomes unstable and it too escapes. Then Earth will be alone, a solitary traveler carrying one memory of light. The asteroid belt and the falling dust between Mars and Jupiter. The asteroid belt begins to disperse. Freed from the sun's gravity, millions of rocky fragments shoot outward, each on its own unique trajectory. Some collide, forming slow-moving clusters that drift together for centuries. Others scatter into interstellar space, forming vast clouds of cosmic dust that trace faint silver paths through the galaxy. The Kuiper Belt, too, the frozen ring beyond Neptune, unravels. Pluto and its icy neighbors begin their long escape. Their orbits no longer curved, but straight, like spears flung into eternity. It's a cosmic diaspora, the family of the sun scattering to the winds of the galaxy. The Oort cloud awakens. Far beyond the known planets, at the edge of the solar system, lies the Oort cloud, a vast sphere of icy bodies, trillions of kilometers away. The birthplace of comets. For eons, it has slumbered, disturbed only occasionally by passing stars or the gravity of the sun itself. With the sun gone, the Oort cloud awakens. Each icy fragment, once held loosely by the sun's faint pull, is now completely free. Some drift outward, lost forever. Others, disturbed by mutual attraction, begin to collide, creating brief flashes of light that will never be seen. In time, the Oort cloud dissolves into the interstellar medium, its icy members joining the endless dust between stars. The sun's outermost boundary has vanished, leaving only emptiness behind, the wanderers of the galaxy. As centuries pass, the former planets of our solar system continue their journey through the Milky Way. They are now rogue planets, unbound to any star, drifting in the cold void between suns. Astronomers already suspect that billions of such planets exist, formed or ejected from their systems. Now Earth, and its siblings have joined them. They travel silently through the galactic dark, invisible to the naked eye, seen only by the faint infrared they still emit. Occasionally, one might pass near another star, close enough to glow faintly in its light, to cast a fleeting shadow on a new sunlit world, and then drift on again. They are cosmic nomads, carrying the memory of their origin through eternity. The legacy of the solar system. Though the solar system as we knew it is gone, its essence remains written across the galaxy. Fragments of comets and asteroids, the frozen shells of planets, the dust of ancient collisions, all continue to drift, spreading the atoms of our sun outward. Over billions of years, some of that matter may be captured by other stars, drawn in by gravity, heated, melted, and reformed. It might someday help create new planets, new moons, new life. In that sense, the solar system never truly ends. It simply changes form, dispersing into the galaxy like pollen carried on an eternal wind. Our star may be gone, but its legacy becomes part of something larger, the infinite recycling of matter, the cosmic rhythm of birth, drift, and rebirth, the beauty of becoming unbound. It is strange and somehow peaceful to imagine this fate. The solar system, once a perfect machine, now dissolved into gentle chaos. Every planet, every moon, every grain of dust moving freely through the dark, following only the silent mathematics of motion. There is no more center, no more orbit, only drift, graceful, eternal, inevitable. And perhaps that is not an ending at all. Perhaps this is what freedom means, on a cosmic scale, to no longer circle, but to journey. The planets were born of the sun's fire. Now they return to the stars. Section 13. The Ghosts of Light, the echoes of the sun through the galaxy. The sun has disappeared. Its warmth no longer touches Earth. No radiation hums across the solar wind. No golden rays rise over alien worlds. And yet, light remains. Because light, once born, never truly dies. It travels forever, carrying the fingerprint of its origin across time and space. Every photon that ever left the sun is still moving, still racing outward, still whispering into the infinite dark. The star may be gone, but its ghost is everywhere. A final wavefront. At the instant the sun vanished, its final burst of light was already 8 minutes away from Earth. That last wavefront, the last sunrise, the last glimmer, continued on its path through the void. 8 minutes later, it reached Earth, then swept beyond the orbit of Mars, Jupiter, Saturn. It passed Pluto and the outer edge of the Kuiper Belt, leaving the solar system in a silent rush of photons. Those rays, the last light of the sun, now travel through interstellar space at the speed of light. They will never slow, never fade completely, never stop. In 1,000,000 years, that final sunlight will have crossed the distance to neighboring stars. In 1,000,000,000 years, it will still be moving, spread across the spiral arms of the Milky Way, diluted to almost nothing, but still real, still sunlight. The sun is gone, but its light will wander forever, the light trapped in time. Every photon that left the sun tells a story, not just of brightness, but of when it was born. Some of the light currently leaving our solar system began its journey thousands of years ago, released from the core of the sun after spending millions of years bouncing from atom to atom within it. The light we once felt on our skin was ancient before it ever reached us. When the sun disappeared, that entire reservoir of photons already in transit through space became its living memory. Each one is a time capsule, a frozen moment of the sun's existence, traveling outward forever. If someone, somewhere, could intercept a single ray 1 billion years from now and analyze it, they could reconstruct everything about the sun: its temperature, its spectrum, its magnetic storms, its age. The light would tell them what we once had and what we lost. The solar wind's last breath. Light is not the only thing that continues. For billions of kilometers beyond the planets, the solar wind, a stream of charged particles released from the sun's corona, keeps traveling outward, forming an expanding bubble around the solar system. That bubble, the heliosphere, once marked the boundary between our sun's domain and the interstellar medium. When the sun vanishes, the outward flow of new particles stops, but the existing wind continues to drift, carried by momentum alone. It expands, thins, and eventually dissolves into the fabric of the galaxy. In that fading sphere of plasma, you could still detect traces of solar activity, a magnetic whisper from a star that no longer exists. Even the particles of the solar wind are ghosts, faint memories of the sun's breath, spreading across light years like invisible smoke. The light that touches other worlds. As the final sunlight moves outward, it will encounter other systems. Perhaps far away, a distant planet orbiting a red dwarf will catch a few photons. Sunlight that left long ago, striking an alien atmosphere for the first and only time. To its inhabitants, if they exist, the light would be indistinguishable from the light of any other star. They would never know that those faint rays came from a vanished sun, a memory of another world. Every photon that touches something else, a dust grain, a comet, a planetary ring, becomes part of the universe's ongoing story of connection. The sun's light, though no longer renewed, still participates in creation. It illuminates other skies. It warms particles in the dark. It continues to be, even though its source is gone. The faint reflection of Earth. Not all of the sun's light escaped. Some of it was reflected by Earth, by the moon, by the planets and their icy rings. That reflected light also travels outward, carrying not just the signature of the sun, but of the worlds it once shone upon. If, in the far future, an alien civilization were to detect that reflected light, they could learn not only that the sun once existed, but that its third planet had oceans, clouds, and perhaps life. The color of Earth's reflection, the faint blue of scattered light, would reveal the fingerprints of water and oxygen. In this way, Earth becomes a secondary source of the sun's echo, a mirror still speaking long after the original voice has gone silent. Even now, Countless photons are racing outward, each one a little message from Earth and Sun alike. They are our fossils of light, the echoes on distant dust. Light never truly stops. It only weakens, spreads, and changes form. Eventually, the sun's photons will be absorbed by interstellar dust, microscopic grains of carbon, silicate, and ice drifting between stars. Those grains will warm slightly, vibrate, and re-radiate the energy as infrared light. The sun's energy becomes part of the galaxy's background glow, a faint warmth that fills the Milky Way. In this way, the sun is never entirely lost. Its energy becomes part of the collective hum of the cosmos, the diffuse light that binds all stars together in the galactic sea. You could say that the sun dissolves, not vanishes, but blends into the greater whole. It ceases to shine alone, yet continues to shine everywhere. The light that outlives everything, even when the last photon from the sun is absorbed and re-emitted. The process never truly ends. Energy cannot be destroyed. The sun's radiance, its warmth, its fusion-born brilliance, all of it continues to echo through the universe, transformed but eternal. The sunlight that once touched your skin might someday help heat a dust cloud that collapses into a new star. That star's light might later illuminate another planet, another ocean, another form of life. The sun's disappearance is not the end of its story. It is simply a change of form, from star to radiation, from radiation to memory, from memory to creation. Light, like life, only changes shape. The cosmic memory. Imagine, millions of years from now, a distant observer looking into the galaxy. They detect a faint, diffuse glow, a relic of a long-lost yellow star. They reconstruct its properties, calculate its planets, and wonder about the life that once existed there. In that way, the sun continues to communicate, even across death. Its photons, its particles, its warmth, all are records written into the very structure of the universe. And though no one may remain to remember it, the cosmos itself remembers. It holds the echo of every pulse of light, every spark that ever shone. The sun's story becomes part of that eternal memory, the light that never needed to be seen to be real. The sun has vanished, but its light, its warmth, its energy, its echo continues without end. It drifts between the stars, woven into the very fabric of time, until the universe itself cools to stillness. Even then, the memory of that light remains, in dust, in atoms, in the quiet hum of background radiation. The sun is gone, but its ghost still shines everywhere. Section 14. The fate of the galaxy when the stars themselves begin to die. The sun is gone, but in the vast ocean of the Milky Way, its loss is barely a ripple. Hundreds of billions of other stars still burn, each one with its own worlds, its own gravity, its own stories. From a distance, the galaxy still glows, a slow spinning wheel of light and dust, arms curling like silk ribbons through space. It looks eternal, but even galaxies have lifetimes, and what we see today This great luminous spiral is only a brief chapter in a far longer story. This is what will happen to the galaxy itself as time moves beyond stars, beyond light, beyond even memory. The life of a galaxy. Galaxies are living systems. They are born from the collapse of gas clouds, grow by forming stars, and evolve through mergers and gravity's patient hand. Our Milky Way has existed for over 13 billion years, a survivor of cosmic collisions, a collector of smaller galaxies and wandering stars. It has seen the birth and death of countless suns. But galaxies, like the stars within them, are not immortal. Their light is a sign of youth, of fuel still burning. As that fuel runs out, the galaxy begins to fade, growing quieter century by century, until it becomes a shadow of its former self. In this way, the death of our sun is not just a local event. It is a small echo of the galaxy's slow decline. The future sky. If someone or something were still alive on one of the rogue planets ejected when the sun vanished, the view of the galaxy would be hauntingly beautiful. Without the glare of a nearby star, the Milky Way would stretch across the sky like a river of fire. Billions of stars would be visible, each one shining with the light our sun once shared. But this beauty hides a truth. Every one of those lights is also temporary. Stars live for billions of years, but not forever. Massive stars burn fast and die young, collapsing into black holes or exploding as supernova. Smaller stars, like red dwarfs, burn slowly. They may outlast everything else, shining faintly for trillions of years. And so, the galaxy continues its quiet evolution. The bright ones fade first, leaving only the dim, red embers to carry on. The galactic mergers. In about 4 billion years, the Milky Way will collide with its nearest large neighbor, the Andromeda Galaxy. From afar, it might look like chaos, two great spirals crashing into one another. But on the scale of stars, it is more like a slow dance. The stars themselves are so far apart that almost none will collide. Instead, gravity will weave them together, stretching, twisting, reshaping both galaxies into a new form. An enormous elliptical galaxy, sometimes called Milkomeda. In this future cosmos, the stars of the Milky Way and Andromeda will mingle. Their black holes merge, and vast new waves of star formation will briefly reignite. It will be the galaxy's final burst of life, a cosmic rebirth before the long quiet that follows. The dimming of the stars. After the great merger, the galaxy will enter its twilight age. The gas and dust that once fueled the birth of new stars will be used up or locked away inside old, dying systems. Star formation will slow, then stop entirely. The remaining stars will live out their long fates. Red dwarfs shining weakly for trillions of years. White dwarfs cooling like fading coals. Over unimaginable spans of time, even those will darken. The galaxy will transform from a glowing spiral into a vast cloud of faint embers, drifting through the darkness. Each of those embers was once a sun, with its own planets, its own stories, just like ours. The Milky Way, once radiant, becomes quiet, still, a graveyard of light. The silent architects, black holes. Even as the stars fade, one kind of object grows more powerful: the black holes. At the galaxy's center lies a supermassive one, Sagittarius A star, millions of times the mass of our Sun. As other stars die, many will collapse into smaller black holes. Over trillions of years, these dark giants will dominate what remains. They will wander the galaxy, consuming the faint remnants of matter, gas, dust, stray planets, even the cores of dead stars. Gravity will slowly pull them together, until eventually only black holes remain, a population of invisible titans circling the galactic center like silent sentinels. The Milky Way will become a kingdom of darkness, its light consumed, its brilliance remembered only in the radiation echoing across the universe. The galactic ghost light. Even in this age of darkness, there will still be a faint glow. The decaying particles of old stars, the slow evaporation of black holes. The faint background of cosmic radiation, all will combine to create a thin, ghostly shimmer. It won't be visible to the eye, but to the universe itself, it will still be there, a residual hum of what once was. The galaxy, in this far future, will not vanish entirely. It will become a whisper, a vibration of energy, a soft murmur beneath the silence of eternity. In that sense, the galaxy does not die. It fades into the background, merging with the greater whole, the same way the sun's light became part of the cosmic sea. The longest night. Eventually, every remaining light, even the dimmest red dwarfs, will fade away. The galaxy will become invisible. No stars, no glow, no color. Only black holes, neutron stars, and the quiet remains of matter drifting through space. It will be the black era of the universe, an epoch when the cosmos is no longer illuminated, when everything that once burned has cooled to near absolute zero. Yet even here, the story does not end, because gravity still works, time still flows, and every particle still carries the memory of light, the galactic memory. Every atom that ever formed a star, every photon that ever crossed the void, every trace of gravity that shaped the Milky Way, it all remains, encoded in the very structure of space-time. The galaxy's light may fade, but its influence endures forever. Its gravity has shaped the paths of countless worlds. Its radiation has seeded new life. Its collisions and expansions have changed the destiny of matter itself. When the last star burns out, that memory remains, written in the shape of the universe. And even if no being is left to remember, the galaxy remembers itself, through motion, through pattern, through the elegant stillness that follows creation. The peace of the cosmic night. It is tempting to see this as a tragic story, the fading of light, the death of stars, the cooling of all things. But there is also serenity in it. The galaxy's death is not violent. It is a long exhale, a peaceful surrender. The same energy that once flared in suns and storms now rests quietly in the background, distributed evenly, harmoniously. The Milky Way does not vanish. It transforms, just as the sun did, just as all energy does. And in that final stillness, there is beauty, a beauty beyond light, a beauty of completion. The galaxy sleeps, and the universe listens. Section 15. The universe after everything, the final quiet. There comes a time when even eternity seems to rest. A time when all light has faded, all warmth has escaped, and all motion has slowed to a whisper. This is not destruction, it is completion. The universe, once vibrant and alive with stars, has entered its final age, the dark era. It began with fire, the Big Bang, the birth of light, the creation of matter. Then came the age of stars, the galaxies, the swirling structures of dust and time. But now, after trillions upon trillions of years, all of that energy has spread thin. The cosmos has cooled, and what remains is the quiet memory of everything that ever was. The slow fade. For eons, light defined the universe. It shaped time, life, and meaning. But light once released always travels outward. It never comes back. Over billions of years, every photon that was ever emitted has been stretched by the expansion of space itself. Its wavelength has grown longer, its energy weaker, until it no longer glows, but merely hums, a faint vibration lost in the vastness. This is the fate of all radiation, to fade, not because it dies, but because space grows. And so, the universe dims, not suddenly, but gradually, like the embers of a fire cooling beneath an infinite sky. The galaxies have gone dark. The last stars have burned out. The black holes remain, their hunger endless, their silence complete. The rule of the black holes. In this dark future, black holes are the masters of everything. They have devoured what remained of the stars and planets, swallowing light, time, and matter alike. Across the cosmos, they drift like invisible monarchs, their gravity bending what little remains of space around them. Each one is a memory, a grave, a remnant of the light that once was. For countless eons, they endure, gathering what little they can. But even black holes are not eternal. Over unimaginable spans of time, they begin to evaporate, a process known as Hawking radiation. They lose mass, particle by particle, until finally, even the largest black hole shimmers away into nothingness, releasing one final burst of energy. The last light in the universe will not come from a star, but from the death of a black hole. And when that last spark fades, the cosmos will finally be dark, completely, perfectly dark. The age of dust and silence. After the black holes fade, only the simplest forms of matter remain. Cold particles, protons, electrons, neutrinos, drifting alone through an almost empty sea. These particles rarely meet. The universe has expanded so vastly that even encounters between atoms become impossibly rare. Collisions, reactions, chemistry, all have ceased. The cosmos has become smooth, still, quiet. Space continues to expand, but now it stretches emptiness itself. In that boundless stillness, time loses its meaning. There is no more day or night, no more change, only the soft hum of existence, the residual energy of being, the last light, if you could somehow exist then, not as matter, but as awareness. You would find beauty in the faintest trace. There would still be radiation, stretched to almost infinite wavelengths, invisible but present. There would still be motion, tiny fluctuations, quantum ripples that never entirely rest. And there would still be gravity, curving even the emptiest regions of space. The universe never stops completely. It only grows still. Like a pond after the last drop of rain, it holds the memory of movement in its smooth surface. That surface, the fabric of space-time, is the ultimate archive. Every star that ever shone, every galaxy that ever spun, every life that ever breathed, all are written there. In the delicate curvature of reality itself, nothing is forgotten. The heat death. Physicists call this final stage the heat death of the universe. Not because of fire, but because of balance. Everything has reached thermodynamic equilibrium. No heat flows, no work can be done, no life can persist. Energy still exists, but it is perfectly, evenly spread, like mist across an endless plain. And yet, in that total stillness, there is also perfection. The universe has reached complete harmony. No conflict, no imbalance, no noise. It has not ended in catastrophe, but in peace. It is the grandest quiet that ever was, a silence that contains everything. The memory of light, if there is any kind of memory that outlives even time, it would be the structure of the universe itself. Every event, every photon, every atom that ever existed has shaped the geometry of space-time. Even in darkness, that geometry remains. The ultimate record of creation. Perhaps in some unknowable way, the universe remembers its own story. It has been through chaos and birth, through stars and life, through thought and love. And now it rests, not erased, but complete. The memory of light still hums quietly, buried within the infinite dark, not lost, only resting. The possibility of renewal. And yet, some theories whisper of beginnings hidden within endings. Quantum fluctuations, the tiny, eternal ripples of the void, might someday grow large enough to spark a new burst of energy, a new space, a new time, a new Big Bang. If that were to happen, the ashes of our universe could become the seeds of another. From the silence of one cosmos, another could bloom. And somewhere in that new beginning, new suns might rise, and new worlds might ask the same questions we once did. It would not be repetition, but renewal. The universe in this vision never truly dies. It dreams itself anew, the infinite exhale. And so, after all the journeys, from the vanished sun to the drifting planets, from the death of galaxies to the cooling of all things, we arrive at the edge of everything. There is no sound here, no light, no motion, just peace. The universe has exhaled completely. Every atom, every photon, every life has played its part in the grand cycle of existence. What remains is balance, the soft hum beneath creation, the quiet that holds the memory of fire. And perhaps, somewhere in that stillness, lies the potential for another breath, the echo beyond light. If you could drift through that final night, across the dust of forgotten galaxies, past the ghosts of light, through the frozen remains of time, you would not find despair, you would find calm, because everything that was ever bright, every heartbeat, every spark, has become part of the same great stillness. The sun's warmth, long gone, is still there in the faint vibration of the void. Earth's oceans, now frozen and lost, have become part of the atoms that make up the next horizon of being. All of it, every moment, every life, is woven into the same endless fabric. The disappearance of the sun was never the end. It was the beginning of a journey, one that led, eventually, to peace. The light that once shone upon earth now drifts as a whisper across eternity. And if you could listen closely enough, beyond time, beyond silence, you might still hear it. A soft pulse, a memory of warmth, the echo of a vanished sun, shining forever in the quiet heart of the cosmos.